is problem number 7, section 4. So we're doing the what we call definite integrals. So this actually means we're going to find the area underneath the curve. The curve is the function listed here. So this is a straight line, and we're going from x equals -1 to x equals 0. And I'm just thinking about this. Let me just pause for a second and get the graphing program up. So what we're going to do is we're just going to look at this function and see what. And what we'll do is we'll use the camera to bring it into the thing so we can see what's going on. Okay, so here we are. This is the function, and the function is what we have inside. So we have x minus 2, and we want to go between -1 and 0. So let's go from -2 to +1. So we graph it, and -1 to 0. Okay, so let's go ahead and capture this. And let's switch over. Okay, so there's the function. And it's below the x-axis, so it's actually going to give us a negative area, because what we're doing is we're going to -1, drawing a vertical line which intersects in this direction. We go to 0, and the area is this area. And because it's below the x-axis, we should get a negative result. So let's go ahead and do it. So you just do the antiderivative. So we take this, do the antiderivative, and when you do that, you'll get x squared over 2. Okay, we add 1 to the exponent, divide by the new exponent. The second one is the integral of 2 dx. Well, we have the constant 2, and we integrate dx, which just becomes x. We don't add the arbitrary constant c. What we do is we draw this vertical line to represent that we're going to now take this and evaluate the function at the upper limit and subtract to the lower limit. So we're going to plug the numbers in. So the upper limit is 0. So we're going to get 0 for that because we're multiplying 0 times other stuff. And then we subtract here, so we have -1, which is the lower limit, squared divided by 2 minus 2 times the lower limit, and we get that. So this is the upper limit, subtracting at the lower limit. So we're going to have 0 minus, what do we have? I change this. So you have -1 squared, which is +1, so we'll get +1/2. And then you get negative times a negative is a positive, so that's 2. And so 2 plus 1/2 is 5/2, and so the answer is -5/2. So that is the area. It's negative because it's below the x-axis. If it was above it, then it would be +5/2. Problem number 8. We have the integral of, I don't know why they use V, why they're using V for those two problems, but anyway, it doesn't matter. So this is the area underneath the curve of this function, just a straight line, slope of -3, y-intercept of 4. So when you integrate -3 v dv, you get -3 v squared over 2. And when you integrate 4 dv, you get 4 times the integral dv, which is v. And then you evaluate it between x equals, or v in this case, v equals 2 and v equals 5. So what that means when you evaluate between, it means that you take the function and you evaluate it at the upper limit, which means you just stick in the value of the upper limit in for v. And then you subtract evaluating the function of the lower limit, which means, again, sticking the value of v in there. So let me make sure I put a negative sign there, plus 4 times 2. So that's what that looks like. And so we'll get 25 times negative 3. So we'll get negative 75 over 2 plus 20. So that's the upper limit. And then we subtract. We'll get positive 4. 4 times 3 is 12. So we get negative 12 over 2. And then we'll get 4 times 2, which is 8. Okay, now what do we have? Let's put them all in terms of halves, because we got, this is an odd number, so we have to so we get negative 75 halves plus 40 halves. You just multiply both the numerator and the denominator by 2. We'll get this 12 divided by 6 is 2, but in terms of halves, it's going to be 4 halves. And you get a negative times a negative. And then a negative times a positive is 8. 8 in terms of halves is 16 halves. So now all we have to do is add the numerators. Negative 75 plus 40 plus 4 minus 16 is negative 47. I'm just thinking about this problem. So does that make sense? Well, here's a line that's something like this, because it has a slope negative. That's actually a positive slope, so that's not it. Let's try it again. So negative slope goes to plus 4, so it's going to be something like this, and then it's going to go negative. And so we're going between 2 and 5. Let's see, when does it cross the x-axis? Well, or the v-axis in this case. Well, if this is positive 4, what you do is you set this equal to 0, solve for v, and you get 4/3. So it's somewhere down here, 4/3. So our integration is from 2 to 5. Therefore, it's underneath the curve. And so we would expect a negative area. That's what I was curious about. So I'm just going to pull up my book here, make sure I'm not making any errors. I feel pretty confident about these. Okay, so I get negative 39. Oh, I got negative 39 halves. I got negative 47 halves. Okay. I just probably need a break here. My brain is fried. Oh, I see what it is. It's actually 2. Is that right? 12, yeah, I divided by 2. So that's actually negative 6, or positive 6. Positive 6 is 12 halves. So now if I do all this stuff, if I add those numerators together, negative 75 plus 40 plus 12 minus 6, 16, negative 39. Here we go. Negative 39 halves, which is the correct answer. I'm going to take a break here. This is problem number 9, section 4. So they have the integral from -1, +1 of t squared minus 2 dt. So this is called a definite integral. We're finding the area between this curve, t squared minus 2, and the x-axis between -1 and +1. So let's plot that. So here's our graphing program. So the function is t, I actually use x, because this likes x instead of t squared minus 2. And we are going between, let's go between -2 and +2. So we're looking at the integral between -1 and +1, so that's all below the x-axis. So again, same reason as the previous problem. So let's do that. And let's go back to the smartboard. Okay, so there's the function. You can see x squared would look something like this. It would go through the origin. This is shifting it vertically by 2 units, so it shifts everything down. So what we're doing here is we're finding the area between this curve and the x-axis, and you've got a vertical line here, and you have a vertical line there. Not very good vertical lines, and then we're trying to find this area. And because it's below the x-axis the entire time, we're sure that it's going to be a negative answer. So what we do is we find the antiderivative of this function, and so the integral of t squared, we add 1 to the exponent, divide by the new exponent. Then we have 2 times the integral of dt. The integral of dt is just t. Draw a vertical line, and we have -1 and +1. And now we evaluate this function at the upper limit and subtract the function evaluated at the lower limit. So we have 1 cubed over 3 minus 2 times 1. So that's evaluating the function of the upper limit. And then we evaluate it at the lower limit. There we go. Okay, so what do we have? 1 cubed, that's 1/3, minus 2, you're going to get -5/3. This is 6/3, and this is positive 1/3, so 1 minus 6 is -5. Okay, the second expression, we're going to have -1 cubed, which is going to be -1. So we have -1/3. And then we add 2 to that. So that's going to give us 5/3, positive 5/3. This is positive 2 minus 1/3 gives us 5/3. Notice it's a negative times a negative, negative and a negative, so you add those together and you get 5 plus 5 is 10/3. So the answer is equal to -10/3, and that's the area under the blue curve. One of the things you can do is you can see that you have a symmetric relationship here. So if I were to take the area between here, -1 and 0, and I doubled it, I should get the same answer. So we're going to do that just to prove that's the case. So what I'm saying is that this is equal to the integral from, let's go from 0 to 1. So it's 2 times this area gives us the whole area because of symmetry. So we integrate t squared, we get t cubed over 3. We integrate 2 dt, and we get 2t. And we're evaluating between 0 and 1, and we're multiplying everything by 2. I have to remember a factor of 2 here. So we get 2 times the upper limit. So we evaluate that at the upper limit, and then we subtract. So I'm going to put a big bracket around here. And then we subtract it at the lower limit, which is just 0. So the lower limit, this goes equals 0. And I need to add a page. So what we get is 2 times 1/3 minus 2, which is -5/3 again. And so 2 times -5 is -10. So we get -10/3, which is exactly what we got here. So there you go. That's it. This is problem number 10. And let's see, what is the function? The integral from 0 to 1 of 2t minus 1 squared dt. Now, this is a little tricky because we haven't learned how to do this kind of. We're learning this in the next section. But so the way that we can solve the problem with what we know up to this point is we would just multiply it out. So we would get 4t squared minus 4t plus 1, everything multiplied by dt. And once I multiply it out, then I just have these individual integrals. So I had 4 times the integral of t squared dt from 0 to 1. I have negative 4 times the integral of t dt from 0 to 1. And then I have the integral of 1 dt from 0 to 1. So the integral of t squared is t cubed over 3. So you add 1 to the exponent, divide by the new exponent. The second one, you'll get 4 times t squared, because you add 1 to 1, you get 2, divided by the new exponent, plus the integral of 1 is t, and you integrate. Okay, so that's it. And then you add the arbitrary constant c. Again, you can get an arbitrary constant from each one of these integrations, but we just add them all together and make it into one arbitrary constant. Well, actually, we don't have an arbitrary constant because this is a definite integral. And therefore, we're going to evaluate this whole thing. So I'll put brackets around it between 0 and 1. And so evaluating it at 1, you just plug 1 in. So you get 4 times 1 cubed over 3 minus 4 times 1 squared over 2 plus 1. So that's evaluating the function at the upper limit. And then you plug it in at the lower limit, which in this case, they're all going to go to 0 because every one involves t or t squared or t cubed. So you get, we'll go ahead and do it completely just to, so that's evaluating the function at the lower limit. Just plug it in here. I subtract that, but again, I'm subtracting 0. So I'll get 4/3 minus 4/2 plus 1. And since I can't simplify 4/3 any further, I'm going to find a common denominator, and the common denominator is 6, because I've got 2 here and 3 there. So what do I multiply the numerator and the denominator by 2, because I want to get 6 in the denominator, so you get 8/6. So 8/6 is the same as 4/3. Likewise here, you multiply by 3, so you get 12/6. 12 divided by 6 is the same as 4 divided by 2. And then 1 is just 6/6. And so we add those things together, so you'll get 8 minus 12 is -4, plus 6 is -2, so we get -2/6, which we can simplify because we have a common factor. And so we get, actually it should be positive. I don't know why I put negative there. 14 minus 12 is positive. So that's positive. And I just get my solution manual out again so I can verify that I've done these correctly. So that is problem number 10. Actually, that was number 11. Okay, well, I'll leave that there. Was that number 11? Yeah, it's because I can't read. I haven't got my reading glasses yet. Okay, that was actually 11. Let me just take and make sure that's correct. Yes, it is correct for 11. This is problem number 10. So we get the integral from x equals 1 to x equals 3 of 3x squared plus 5x minus 4 dx. So we can break this up, and you'll get to some point where you won't have to do this. You'll just do it straight. And I'll explain what that would be so you can get practice. So what I'm doing is I am factoring out the constants so that I have something that is, you can look directly up on the table. So we just have x to the n. So we get the integral of x squared is going to be x cubed over 3. The integral of x is x squared over 2. The integral of 1 is x. So that's the integration. Because this is a definite integral, meaning it has limits, we show it at this. This means I'm going to plug 3 in, and then I'm going to plug in 1 and subtract that. So now we evaluate them at the limits. We get 3 cubed over 3 plus 5 times 3 squared over 2 minus 4 times 3. So that's the function evaluated at the upper limit. Then we have the lower limit. We have 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. And that's it. Now we plug them in and we simplify where we can. So those cancel out. So the first term becomes 27. The second term, we have 9, 3 squared is 9, times 5 is 45. So we get 45 halves. And then we subtract 12. So that's the first thing. And then we subtract the second. So 3 divided by 3 is 1. So you get 1 plus 5 halves minus 4. Going back here, if you were integrating this, you'd say, okay, the integral, I'm just going to do each one of these separately, is going to be 3x cubed over 3 plus 5x squared over 2 minus 4x evaluated here. So you can go from here straight to there. You just do each one separately and add them together in your head. Okay, now back down to here. So what's the best way of doing it? I mean, there's a couple of ways you could do it. You could distribute this to each term and then have all 6 terms. So let's do that. So you'd have 27 plus 45 over 2 minus 12 minus 1 minus 5 halves plus 4. And then you could combine the terms that are integers. So you'd have 27 minus 12 is 15, minus 1 is 14, plus 4 is 18. So you'd have 18. 27 is 15, 14, 18. Okay, then you could do the halves part. 45 minus 5 would be 40. So we get 40 halves, which in this case you can simplify to 20. So the final answer would be 38. See, that's right. That's correct. Okay, so that'll be one way. The other way is, you could combine these two. So you'd get 39 plus 45 halves minus, then you'd have negative 3 plus 5 halves. And then you could 39 plus 3 is 42. And then you'd have 45 halves minus, I messed something up there. Oh, it's because it's 27 minus 12, which is 15. And then I could take 15 minus 3, which is, or 15 plus 3. 15 plus 3 would be 18. And then you'd have 45 plus 5 is 50. 50 half, oh, it's actually minus. I like the first way better because I'm messing up the second way. 45 minus 5, which would be 40 halves, which is 18 plus 20, which is 38. Okay. Okay, we're going to do number 15. So we have the integral, the definite integral from 1 to 4 of u minus 2 divided by the square root of u all times du. So again, when you have numbers, that means you're finding the area between this curve and the x-axis and the vertical lines at x equals 1 and x equals 4. So let's go to the graphing program. And what we're going to do is we're going to put in that function. So we have x minus 2 divided by the square root of x. So that's the function. And we're going to go between 1 and 4. So let me put in 0 and 5. So we have a little bit on either side. So there it is. And let's go ahead and capture that. And we'll go back to Smartboard. So there we go. Now let's draw our vertical lines. So we go from x equals 1, which is right here, to x equals 4, which is right there. And so we're going to have two areas. We're going to have this area, which is negative, and we're going to have this area, which is positive. And just looking at it, it looks like this area is less than that area. So we should end up with a positive number. I'm guessing this is 1 unit, that's 1 unit. It's going to be close to 1, because what I'm thinking is this area is about equal to here. And so the net area is going to be this little bit there, which is 1 unit wide by about 1 unit high. It's going to be less, probably a little bit less than 1. So in this case, we just rewrite the original equation first by dividing each thing by the square root of u. So we change this to two terms. And u divided by the square root of u is just equal to the square root of u. This is the first power, this is the half power. So what you end up with is u to the 1/2 power here, and then we subtract 2 times u to the minus 1/2 power, because that is, I'm rewriting this as u to the half in the denominator, becomes u to the negative 1/2 in the numerator. Okay, now I'm going to rewrite these, and I forgot my limits, so let's not forget the limits. So put the limits on there, we break it down into two integrals. Factor out the 2 in the second term. Put the limits back on here. Okay, so u to the 1/2 times du, the limits are the same. I factor out the negative 2, and I have u to the negative 1/2. So you add 1 to the exponent, so you get u to the 3/2 divided by 3/2 for the first term, and then we have 2 times u to the positive 1/2 divided by 1/2, which are our vertical line to show what the limits are. We don't need to include the arbitrary constant, because that's going to cancel out. Okay, let's simplify this before we actually plug something in. So we get 2u to the 3/2 divided by 3. So I take the reciprocal of 3/2. And if I take the reciprocal of 1/2, I get 2. So I get 2 times 2. So I get 4u to the 1/2. Again, I'm evaluating that between 1 and 4. Okay, that looks correct. Now I plug the values in. So I get 2/3. The upper limit is 4. So 4 to the 3/2. And then I have 4 times 4 to the 1/2 power. So that's evaluating the function at the upper limit. And then I subtract evaluating the function at the lower limit, which is 1. And And these limits are chosen actually so that we don't have to use our calculator. So the first one is basically you take the square root first. So you do the 1/2 part. Square root of 4 is 2, and then you cube it. So we'll end up with 2/3 times 8, 4 to the 3/2. Okay, the second, we're going to have 4 times the square root of 4, which is 2. So that becomes 2. Okay, that's our upper limit. And our lower limit, 1 to any power is 1. So you get 2/3. And then we subtract 1 to the 1/2 power, which is 1 also. So you just get 4. So we'll have 16/3 minus 8. And we'll have negative 2/3 minus 4. Okay, so let's distribute the negative sign. So we'll get 16/3 minus 8 minus 2/3 plus 4. So that becomes negative and that becomes positive. And let's put it all in terms of thirds. So if you multiply it by 3, you'll get 24/3 minus 2/3 plus multiply by 3, so that's 12/3. Okay, now we just add them all together. So you get negative 8 minus 2 is 10 plus 12 is 2. 2/3. 16 minus 24 is negative 8. Another negative 2 is negative 10. Negative 10 plus 12 is 2/3. I said it was going to be positive, and it was going to be probably a little less than 1, which it is. There you go. So that makes me feel good. Okay, problem number 16. Okay, so we have the integral from -1, no, actually -3, -3 to +3 of the curve b to the 1/3 dv. So it's still a polynomial. It's just got a fractional exponent. So we know n is equal to 1/3. Therefore, n plus 1, which is what we're looking for, is 1 plus 1/3, which is 4/3. So when we integrate it, the integration of v to the 1/3 gives you v to the 4/3 divided by 4/3. And because it's a definite integral, we're going to evaluate from x equals 1 to x equals -3 to +3. So that becomes 3/4. 4/3 dividing by 4/3 is like multiplying by 3/4. So then we have v, which is 3 at the upper limit, raised to the 4/3 power, minus -3 raised to the 4/3 power. And what are we going to get here? We're going to, I think it's going to involve some kind of root. Well, actually it's not, because it turns out these are going to be exactly the same. Why is that the case? Well, let's think about it. I mean, you can plug in your calculator and you find out that's true, but basically this is 3 to the 4th power, and then you take the cube root and you subtract -3 to the 4th power, and you take the cube root. Well, 3 to the 4th power and -3 to the 4th power are the same thing. So you can see they end up being the same magnitude because you lose the negative here, so you'll have plus. That's one way of looking at it. If you wrote it as 3 to the 4th, actually, if you wrote another way of writing would be the cube root of 3 raised to the 4th power. Now that's a little, well, I think we can still, let's put this times 3/4. 3/4. Okay. So then you have the cube root of -3. So what happens with the cube root is that the cube root of 3 is whatever the number is. So let's just take 3 to the 1/3 power. 3 to the 1/3 power, and you get 1.44. Okay, so it's 1.44 to the 4th power. And if you take -3 to the 1/3 power, you should get a negative of that. You'll get negative. You'll get negative 1.44. But then you raise to an even power, so you lose the negative when you do that. So you can get rid of the negative here when you take it to the 4th power. Then you'll have two positive numbers. Or if you do it this way, you'll end up with a positive number and negative number when you do the cube root. When you raise it to the 4th power, then you lose the sign again because it's an even power. So it turns out the answer is 0. And let's just look at this. Let's look at this function visually, just to show you why it is. Because it's a symmetric function, but it's symmetric about the origin. So let me stop sharing that. Start sharing it. So the function is x to the 1/3. Same as the cube root. And we're going from -6 to +6, so we'll graph that. So there it is. So what happens is, in our particular case, we're going from, let's change the view from trig pi. Okay, so basically we're going from here to there. So you can see it's symmetric. This one has a negative area, this one has a positive area. So because they're equal, the shapes are exactly the same. They're symmetric around the origin. Then they cancel out. Now if we went from -4 to +2, then we probably have a negative area. If we went from -2 to +4, we'd have a positive area. This is problem number 20, section 4. So we're doing the definite integral from 0 to 2 of 2 minus t times the square root of t times dt. Okay, so let's again look at what this curve looks like. So the function is 2 minus x times the square root of x. And we want to go between 0 and 2, so we'll go between -1 and +3 as far as graphing. -1, +3, graph the function. So there we go. And so let's go ahead and capture this thing. Okay, where'd it go to? Now let's try that again. I'm just going to do it and hopefully it'll show up here. Okay, there it is. Don't know where it went to before. Anyway, that's the function. Let's look at it on one page here so we can see a little better. So what we're doing is we're doing the integral between 0 and 2. So actually, the vertical lines don't exist here because this intersects the axis of those two. So we're looking at this area under. So it's going to be positive for sure. And what do we think it's going to be? Well, here's 2, and here's 1. So it's going to be less than 2 times 1. So it's going to be, and 1 would be this area. So it's definitely going to be bigger than 1. And less than 2, I'm guessing like 1.5, something like that. Okay, so now we know what to expect, at least. Now to do the integral, before we do that, we're going to multiply this out. So we'll get 2 times the square root of t minus t to the 3/2 power dt. So, of course, 2 times the square root of t is 2 square root of t. Here, this is to the first power, this is to the half power, so you add the exponents, and you get t to the 3/2 power. Okay. Take the antiderivative. Actually, before we do that, though, we need to rewrite this as t to the 1/2 power. So we have rewritten the original expressions as fractional exponents. Okay, so the integral of the first one, we have the constant, we add 1 to the exponent, and we divide by the new exponent. In the second case, we add 1 to the exponent, and we divide by the new exponent. Then we draw a vertical line to show the limits. So before we stick the limits in, let's fix this up. So I'm not going to, I always forget to put equal signs here. Okay, so I'm going to just be explicit about what I'm doing here. So we take the reciprocal of the denominator to multiply it out. And so we're going to get that. So the 2/3 becomes 3/2 becomes 2/3, and the 5/2 becomes 2/5. Okay, so that'll be 4/3. So let's do so first term is 4/3. T at the upper limit is 2. And then we have 2/5 times 2 to the 5/2 power. So that's evaluating it at the upper limit. And the lower limit is 0. Because anytime we have a polynomial or anything that has an exponent and you have a lower limit of 0, you can just say it's a 0 because t to the 0 is 0 and t to the 0. T to the 3/2 is, pardon me, 0 to the 3/2 is 0 and 0 to the 5/2 is 0. So you add 0 and 0 and you get 0. Now the second part we can't really do except we'd have to put it in terms of square root of 8 or something like that. So let's just do it in decimal form in this case. So we get 4/3 times 2 to the 3/2, and let me finally get my calculator out. And where's my calculator? Hopefully I didn't leave it in class. Oh, there it is. I didn't think I did. Okay, so 2 raised to the 3/2 power is 2.8, which is the square root of 8. 2.828. And then we subtract 2/5 times 2 to the 5/2. 2 to the, make sure you put those 5/2 in parentheses. So that's going to be 5.657. 4 times 2.828 divided by 3 minus 2 times 5.657 divided by 5 is 1.5. Hey, that's pretty close to what I thought it was going to be, 1.508. So if you go back again, the reason I guessed that was this area was all the way here was, this is 2 units, this is 1 unit, so that rectangle would be 2. If we did the rectangle to here 1 by 1, then that's 1 unit. So this thing has a little less than 1 there, but it's got more as this thing expands out. So that's how I guessed 1.5. So I'm pretty confident that's correct. This is problem number 20, which is very similar to, is this 20 or 21? 21, which is very similar to the last problem in the assignment if you've done that already, or if you've watched the video, because we have 2 terms. We have t to the 1/3 and minus t to the 2/3. So just like with differentiation, we can take the individual integrals. So this becomes the integral from -1 to 0 of t to the 1/3 dt, and then we subtract the integral from -1 to 0 of t to the 2/3 dt. These are just polynomials, so we use the power rule. So when we integrate t to the 1/3, we add 1, we get t to the 4/3, we divide by 4/3. When we integrate t to the 2/3, we get t to the 5/3, divided by 5/3. So that's the integration, and then we evaluate the integral between the two limits. Okay, so I'm going to take the reciprocal, so I'll have 3/4 times t. At the upper limit, it's 0, so we take that to the 4/3. We subtract 3/5, 0 to the 5/3. That's the upper limit. In this case, the upper limit is 0. The function evaluated the upper limit. Then we do the lower limit. So we get -1 to the 4/3 and minus -1 to the 5/3. Okay, so the first part's 0. 0 to any power is 0, except I guess 0 to the 0 power, maybe. Can't remember that. So then you subtract off the lower limit. And so we got 3/4 times, okay, -1 to the 4th power, we need +1. The cube root of +1 would be +1, so we get 1. And the second one is the cube root of -1 is -1. And raise that to the 5th power is -1, so it's -1. And I left off the 5/3, so I need to fix that. Or 3/5, so I got 3/5. Okay, so you got 3/5 times -1. So we end up with negative the quantity 3/4 plus 3/5, because you have negative times a negative is positive. So we have a common denominator will be 20. So that means we'll get 20ths here. So multiply both by 5 to get 4 times 5 is 20. And then here we multiply by 4. 4 times 3 is 12 divided by 20. So that's equal to 27. So we have -27 20ths. And that's problem number 21. So let's just check. -27 20ths. That is correct. So let's go to the graph. A lot of times we forget, we just don't bother looking at the graph, but I think it's worth looking at. So let's, and it says the area is negative. I don't want to do that. I want to change the graph. So there it is. So what we have is x to the 1/3 minus x to the 2/3. And we graph that. And it's not letting me have the function defined at a negative number. So why is that? It should. I think it's just some way that I've written this expression. Okay, let me think here. What I can do is I think I need to go, I go x squared raised to the 1/3 power. How about that? That would be one way of doing it. Okay, now graph it. Ah, there we go. So that's the other part. So we're going from -1 to 0. So it's this area right here. And you just think about it in terms of this is 1 unit and this is 2 units. So if I took this rectangle, it would be 2 units. And so this would be 1 unit. I go 1 by 1. So it's going to be between 1 and 2, between -1 and 2, -1 and -2, because it's going to be, this is -1, this is -2, so you can see it's somewhere between. And that's what it is. If we go back to the solution, we got -27/20, which is a negative number because the curve is below the x-axis. And it's pretty obvious it's always below the x-axis. Now, if someone was above and someone was below, then you're not exactly sure. You'd have to eyeball it. Okay, let me pick another one here. Yeah, I can ignore the absolute value things, which maybe is not a good idea. Yeah, we'll do an absolute. Well, we'll do that next. So we'll do one more of these. So we'll do 22. And so 22 is the integral from -8 to -1 of x minus x squared over 2 cube root of x, whole thing times dx. So this is the definite integral. This is the function that we're trying to find the area underneath. And those are limits. This is called the upper limit and the lower limit. So we're going to switch over to the graphing program to graph this thing. So let's see, let me write this down. So we have x minus x squared divided by 2 times, we're going to say x to the, I don't need a capital X, apparently, there we go, x raised to the 1/3 power. So that's x minus x squared over 2 times x, cube root of x. Okay, and we're going to go from -9, because we have our limit from -8, and we're going to go to 0 on our graph, and we get that. So let me zoom out in the x direction. Okay, so there's -8, there's 1. It's going to be positive, as you can see, because the red curve is above the x-axis. So we're going to capture that. And we're going to go back. So where we are. Okay, so there's our function. So let's go to one page and look at this thing. So what we're doing is we're going to draw a vertical line from x equals 8, -8, to the function. We're going to draw a vertical line from x equals 1 to the function. And so the area we're talking about is this area between the red curve and the x-axis and the vertical lines. So it's going to be positive. So what's going to be a good estimate of this thing? Well, let's see. The y value here is 18, and the base of a triangle. What I'm going to do is draw a triangle and say it's going to be a little bit less than that triangle. So what I'm going to do is, actually, what I'm going to do is I'm going to draw a line from here and go to 0 because it's, or go to there. That's probably good. Yeah. So my base is 7. My height is 18. So let's just do our little estimate. So the area of that triangle is 1/2 the base times the height. And the base is 7, and the height is 18. So that's 18 divided by 2 is 9. 7 times 9 is 63. 63. So let's say the answer should be approximately 63. It's probably going to be a little less than 63 because this is under predicting it. I mean, this is under predicting it. This is over predicting it. So it's going to be a little a little less than 63. So let's guess 58. I want to choose 58. Okay, we'll see what happens. Put your bets in. Okay, so what we're going to do is we are going to divide everything out here. So one thing we could do is we could take the half out to start with. So we don't have to worry about that anymore. And then we'll have x divided by x to the first power divided by x to the 1/3 power. So the first one will become x to the 2/3 power. 1 divided x to the first, subtract a third, you get 2/3. Okay, the second one, same kind of deal. You've got x squared, so you have 2 minus a third, which is going to be equal to 5/3, and that all is multiplied by dx. So we could break this up into 2, but I'm just going to do it. You add 1 to the exponent, so let's put the 1/2 out front. So you can add 1. 1 to 2/3 is 5/3. Because 1 is 3/3, so 3 plus 2 is 5, so you get 5/3. And you divide by the new exponent. And then we have x to the, add 3 to that, 3/3 to that, you'll get 8/3. And we divide by 8/3. So that's the antiderivative. And then we're going to evaluate between negative x and negative 1. Okay, let's just multiply these out and simplify. So you're going to have a half. Take the reciprocal of that will be 3/5. So 3/5 times 1/2 is going to be 3/10. So we get 3/10 x to the 5/3, and likewise take the reciprocal of that, and you'll have 3/16 times x to the 8/3, all between -8 and -1. Now you could just plug this into your calculator, but and that'd be fine. But I'm going to show you how to do this without using your calculator. Because what you'll do is if you take the cube root of -1, you get -1. Because -1 cubed is -1. So the evaluating this at the upper limit. So we're going to, and so you take the cube root of -1 is -1, and then you raise it to the 5th power, which is -1 to the 5th power is still -1 because it's odd. So we get -1 for that first one. Okay, then we have 3/16 times, okay, now we stick in -1. Again, -1 cubed is the cube root of -1 is -1, but then you take it to 8th power, which is going to be equal to +1, because it's an even power. Anything raised to an even power becomes positive, and anything raised to a odd power, if it's originally negative, stays negative. Okay, so that's the upper limit. And then we subtract to that the lower limit. So we have 3/10 times, okay, -8. The cube root of the -8 is -2. Then we raise -2 to the 5th power, which is going to be equal to -32. Because 2 to the 5th power, 2 times 2 times 2 times 2 times 2 is 32, but if you have a negative sign. Likewise, the second term, you're going to have, it's going to be positive, and the cube root of -8 is -2, and then you take -2 to the 8th power. So what is 2 to the 8th power? 2 to the 8th power is 256, but it's going to be positive. 256. Okay, so let's see what we have here. So, so we're going to have -3/10 minus 3/16. Here we have negative times a negative, which is a positive. So we're going to have positive 3 times 32 is 3 times 32 is 96. 96 tenths. And then we're going to have plus, negative times negative is positive. So before we do that, though, 256, I think you divide by 16, so let's do that. Yeah, it's 6. So this thing here is 16. So all you have to do is take 3 times 16. That's 48. 48. Okay, you see it's going to be positive because these are small. The negative numbers here are small. Accidentally push the off button, so can I get this thing going again? Oh, there, where is it? I saw it move. Okay, let me turn this off again. Okay, there we go. Okay, so let's just do, again, we're doing this as fractions. So what do we have to find some common denominator. And so what's the common denominator we have? Well, you've got 10 has, so this is made up of 2 and 5. This is made up of 2 times 2 times 2 times 2. So what you do is you take I think 4 times 5, or not 4 times 5. You're going to, I've forgotten how to do this now already. You've got this common 2, so I think it's 2 times 5 times 2 times 2 times 2. So that would be 8, 40. No, it's not going to work. So you're going to multiply it by again. So 80. So 8 times 10 is 80, and 5 times that is 80. So 80ths. So we're going to have negative 24 80ths. So I'll multiply both the numerator and the denominator by 8. In this case, I'm going to multiply it by 5 to get 80. And then I have this times 8. So 96 times 8 is 768 80ths. And then I multiply 48 times 80, which is 3,840 80ths. So now we just add the numerators together. So we have negative 24 minus 15 plus 768 plus 3840. That gives me 4,569 80ths. Now you can't, I don't think you actually can simplify that any. This is because this is even, but that's not, so you can't divide by 2. You can't divide 80 by 3. You can't divide that by 5, so I think we're just going to do it, and I get 57.1. Okay, how does that compare with my estimate? 63, I said it was going to be less than 63. So that's actually pretty close. I can't remember exactly what my guess was, but it looks pretty close to what I guessed. So let's just go back and review what we did. I rewrote the original expression. I factored out the half. X divided by the cube root of x is x to the 2/3. X squared divided by the cube root of x is x to the 5/3. You just subtract 1/3 from each one of those exponents. When you integrate it, you add 1 to the exponent. So 2/3 plus 3/3 is 5/3. 5/3 plus 3/3 is 8/3. You divide by the new exponent. So we divide by 5/3 and 8/3. We simplified. We took the reciprocal of 5/3, which is 3/5. 3/5 times a half is 3/10. Take the reciprocal of 3/8, and you get 8. The reciprocal of 8/3 is 3/8. So you get 3 divided by 2 times 8, which is 16. Then we evaluated these two things, first at the upper limit and then at the lower limit. So I said negative 1 to the 5/3 is negative 1, because the cube root of negative 1 is negative 1. Negative 1 to the 5th power is negative 1, so you put that in there. Here, we had 8/3. So again, the cube root of -1 is -1. -1 to the 8th power is +1. At the lower limit, which we subtract, you get 3/10 times 5 to the x to the 5/3. The cube root of -8 is -2, because -2 cubed is -8. So you take the cube root, you get -2. -2 to the 5th power is -32. Over here, again, the cube root of -8 is -2. -2 to the 8th power is +256. Here we had -1 times 3/10. +1 times -3/16. Here we had -32 times -3, which would be +96 divided by 10. In this case, I divided 256 by 16 to get to 16. 16 times 3 is 48. This negative times that negative gives you a positive. Then I said, okay, we've got a common denominator of 80, because 8 times 10 is 80, and 5 times 16 is 80. So I multiplied the numerator and the denominator by 8, by 5, by 8, and I multiplied both of the numerator and I multiplied the numerator and the denominator by 80 because it's not a fraction yet. So then I add all the exponents together. -24 plus -15 plus 768 plus 3840. I get to here and I say, okay, I can simplify if I want to, because I had estimated as a decimal, so I wanted to get a decimal result. You could just leave it as this if you wanted to. I don't believe there's any common factor. This thing could be divisible by 3, but that's not. This is divisible by 5, but that's not. It's not divisible by 7, 11, 13. It's divisible by 15, but this is not divisible by 15 because it doesn't have a 5 at the end, so I can't see any common factor. So we just multiply it out and get the answer. Okay, this is one of these absolute value problems, so let's look at 23. So it's looking for the integral from 0 to 3 of 2x minus 3 dx. So where this goes to 0 is kind of a critical point, so let's just solve that. So if you get 2x is equal to 3, x is equal to 3/2, so that's halfway between. So the way you work it is basically what the absolute value means that when you're above 3/2, y equals 2x minus 3, and when you're below 3/2, then you use the negative of that quantity. So what we can do is we can break this up into two integrals. The integral from 0 to 3/2 of negative 2x minus 3 dx. And the second part is the integral from 3/2 to 3 of 2x minus 3 dx. Another thing you can do is just use the factor of symmetry. You could just do this one and do one of these and multiply by 2. That would be another way of doing it. That would only work if this number is in the middle, you know, exactly between 0 and 3. So if you went from -3 to +3, then you'd have to do it this way. You go from -3 to here and from there to 3. So you wouldn't go halfway. This breaking point is where this thing goes to 0. And I'm just thinking, let me just check the solution manuals to see which one they decide to do. Use symmetry or whether to okay, this is section 4. So they break it up into two parts, just like that. Okay, so they do it the way that I do it. Hold on just a second. Just something I saw. Let me pause for just a moment. So this is 23 again. Okay, let me look at this. 3x minus 2. I think at 3x minus 2. Absolutely, 2x minus 3. Oh, I get it. What they did, they have is 3 minus 2x, which is the same as negative the quantity 2x minus 3. Okay, so that's what was confusing me. So we're still good. Okay, so let's factor out, well, yeah, put a negative sign out there, and if we integrate 2x, we'll get x squared 2 times x squared over 2, because the integral of x is x squared over 2 multiplied by 2. Okay, then you subtract 3x. So that's the first integral, and we go between 0 and 3/2. The second integral will have 2x squared over 2 minus 3x between 3/2 and 3. Okay, so we get x squared. So let's this will simplify. So we have negative x squared. So let's do that. X is 3/2. We square that. Negative times negative is positive, so we get positive 3 times 3/2. So that's the first integral evaluated at the upper limit. The second limit's going to be 0 because we have x equals 0, so let's go to 0. Then you have your second integral, which is x squared. So in this case, x is 3, and we subtract 3 times x, which is 3. So this is x squared minus 3 times x. That actually goes to 0 as well. And we subtract the thing integrated or evaluated at 3/2. So we get 3/2 squared, because this is x squared. And let's see, am I doing something? This should be plus. No, that should be minus, right? Because this is the lower limit. And so we have negative 3 times 3 times 3/2. And that. Okay, so this integral evaluated the upper and lower limit. This integral evaluated the upper and lower limit. So we'll get negative 9/4 plus 9/2, and then we'll get plus 9 minus 9. So that part goes to 0. Then you'll have negative 9/4 plus 9/2. Again, negative times negative is a positive. So that'll be 18/2. 9/2 plus 9/2 is 18/2. And then we'll have negative 18/4. Okay, multiply that by 2, you get 36/4 minus 18/4, which is going to be 18/4. And that should be the answer. So let me just go back in here. I should have just left it open to that page instead of having to go back and look at it. So this is 23 9/2. 18/4, same as 9/2, so that is correct. So we could simplify this last thing. If you divide both by 2, you get 9/2, which is the answer. And notice if I evaluated it, the first one and multiplied by 2, this part multiplied by 2 is the same as that. So it doesn't work out from a symmetry standpoint. Okay, 27. So it says evaluate the definite integral of the trigonometric function. Use a graphing utility to verify your result. Okay, I think we can actually do that with the graphing program that I have. So I will show you how that works. I think it works. If not, we'll just kind of eyeball the result and not, say we're in the ballpark. Okay, so here's our expression. We have 1 plus the sine of x. So that's the same as breaking it up into 2 parts. Like this. And then we have the sine of x dx. Okay, the integral of 1 is just x. And we evaluate that between 0 and pi. The integral of the sine is negative the cosine. So we get negative the cosine of x evaluated again between 0 and pi. So we get pi minus 0. That's this function evaluated the upper limit minus the lower limit. And then we get the cosine of pi minus the cosine of 0. So the cosine of pi is going to be equal to -1. So this first part just becomes pi. Pi minus 0 is pi. So we get pi. And then we have that minus the cosine of pi. Remember, the cosine is the x-coordinate on the unit circle. So pi x is -1. And the cosine of 0 is the x value there, which is the +1. So we get pi plus 2. So that's your answer, pi plus 2. Negative plus a negative is a negative. You get -2 times a negative is a positive. So that's where you get +2 from. And if we plug this, the number is going to be, well, 2 plus 3.14159. And I don't even need to use my calculator for that. It didn't help because I didn't have my calculator on. So 3.1 is going to be 5.14159. So that's the area underneath this curve. So let's go to the graphing program. And where is it? Here it is. So let's plot that. 1 plus the sine of x. And we want to go between 0 and pi. So 0 and pi. And okay, so that's the graph. And so the integral of 1 is this area, is just this horizontal rectangle. The integral of the sine part is this part underneath. The red curve, between the red curve and the curve y equals 1 would be the second part. So you add those both together. Now, integral, oh yeah, here we go, here's the integral. So the integral of 1 plus the sine of x. And the lower limit is going to be equal to 0 because we're integrating from 0. The upper limit's varying, so we integrate. Okay, so the what have I got here? Oh, okay. So the blue curve is the function. So this blue curve is the sine of x plus 1. The sine of x would be just down here, but it gets shifted by 1 in the vertical direction. So what we're looking at here is the area. And if I zoom out in the y direction, the red curve represents the integral. So right now we have 0 area because there's no width. And then we get to 1, and we've got 2 here, so it's going to be something like, if we just look at this area in the blue curve, this would be an area of 1, this is area of 2, so it's going to be probably about 1.5 or something like that. So if you go to the red curve as the integral, you get about 1.5. So in our particular case, we're going to pi. So let me change the view so the x value is in pi. Okay, so there's pi. So what we're looking at is the integral from 0 to pi. That's the x dimensions. We're looking for this area under the blue curve up till pi. So to find the the definite integral, you put your cursor right there on the red, and you can see it says x equals 1 pi, y is equal to 5.13, which is exactly what we said it was. That's 2 plus pi. Pi being 3.14. And if I wanted to get a better number, I could just zoom in and I could put my cursor as close to the line correctly as possible. And you see I get 5.14. If I go even closer, I'll get 5.14169. Okay, zooming really close, and I get 5.14159. Okay, so you can see that it's approaching 2 plus pi. So that's how that works. That's how the integration feature works on this graphing program. So you can always check your answer. Okay, let's look at problem number 28. So we have the integral of from 0 to pi over 4 of 1 minus sine squared of theta divided by the cosine squared of theta, d theta. Now this may look difficult at first, and I see it, but you might not see it. But we could solve this two ways. Well, we'll solve it the hard way, and I'll show you the easy way. I'll do the hard way first, and then I'll show you the easy way. So the hard way would be to take 1 over, you break this into two things. 1 over cosine squared of theta, d theta, and then you'd have, you should have a negative sign there. So negative sine squared theta divided by cosine squared theta d theta. Okay, so 1 over the cosine is the secant squared theta d theta, and the second one is the tangent squared of theta d theta. Actually, you may not be able to do it this way yet. We could do this in chapter 4 or 5, but we can't do it because we don't have, I don't think we have any derivative, which is the tangent squared. But let's just go back and look. Is the tangent squared anything? Okay, so we don't know how to do this, so we can't do that. If we did, we could do it. But okay, so what is the other way of doing it? Well, the Pythagorean identity, or Pythagorean identity says that. So 1 minus sine squared of theta equals cosine squared of theta. So if I subtract sine from both sides, I get that. And so the numerator can be just rewritten as cosine squared of theta divided by cosine squared of theta d theta. And so that's 1. So then you just integrate d theta. So it just becomes the integral of d theta between that. That's just a horizontal line. You know, it's 1, y equals 1, which is just a horizontal line, is the equation, because we have 1 times d theta. So the integral of d theta is theta, and we evaluate that between 0 and pi over 4. So that means we just plug in the numbers. So you just get pi over 4 minus 0, and the answer is pi over 4. And that was problem number, I forgot what number it was. Just double check here. 28. The answer is pi over 4. Okay, we're up to 29, which is another trig problem. And let's see what we have. We have the integral from negative pi over 6 to positive pi over 6 of secant squared of x dx. So we go to the table on page 250, and we see that the integral of the secant squared is the tangent. And then we evaluate that, the lower limit, which is negative 1/6, up to the positive limit, which is positive 1/6, pi over 6. So when we now plug the numbers in, you get the tangent of pi over 6 minus the tangent of negative pi over 6. So what is the tangent of pi over 6? Besides plugging in your calculator, well, it's the sine of pi over 6 divided by the cosine of pi over 6. Again, you could use your calculator for this. But, you know, back to unit circle days, the sine of pi over 6 is going to be equal to 1/2, and the cosine of pi over 6 is equal to the square root of 3 over 2. So we take the reciprocal of this term, which is 2 divided by the square root of 3. The 2's cancel out. You get 1 over the square root of 3. And to get this in a better form, we multiply the numerator and the denominator by the square root of 3. So that gives us 1 times the square root of 3 divided by the square root of 3 times the square root of 3, which is 3. So that's the tangent of pi over 6. And you could do the same thing for negative pi over 6. One thing you may remember, when you get good at math, you remember this, you know, the tangent function looks like this. It has these vertical asymptotes, plus and minus pi over 2, and then it comes up. It goes through 0 like that, and it comes back up. So you can see that it's symmetric around the origin. So from that, just from the knowledge of the symmetry of the tangent function, I know it's going to be equal to negative the square root of 3 over 3. Because that's the y value. The y value's the negative. Okay, so now we can go back over here. The tangent of pi over 6 is square root of 3 over 3, and we subtract the tangent of negative square root of negative pi over 6, and you get negative square root of 3 over 3, which is this negative times the negative becomes a positive, so you get the square root of 3 over 3 plus the square root of 3 over 3, which means you have 2 times the square root of 3 over 3. So that's your answer. And let's put that in decimal form, because that's what the graphing utility is going to give us. So let's see what we get. 2 times the square root of 3 divided by 3. 1.547. 1.1547. Okay. So, graphing program. Okay, so the function that we're going to do is going to be, actually we're going to need to do the function and its integrand. So we're going to go from negative pi over 6 to positive pi over 6. I'll need to put the plus sign in there, that's redundant. Okay, and the function was secant of x quantity squared, so secant squared. So let's look at that before we do anything. So there it is. So we're finding the area between the red curve and the x-axis. So it's this area right here, all the way over there. You see it's all positive. So we should have positive, let's definitely have a positive area. Okay, let's do the integral now. So let's see, we want to go, well it says from, let's put it from negative pi over negative pi over 6, pi divided by 6, to positive pi divided by 6. And the lower limit is negative pi divided by 6. And the function is the quantity, the secant of x, quantity squared. Okay, hold on a second. I'm just trying to get my eyeballs to see what I got there. I need one additional parentheses. There we go. Integrate. So that's it. And so the blue curve is the function. The red curve is the area. So when you start out here, this is basically doing the integral from negative pi over 6 to some value of x. So when we get to x equals pi over 6, we go up here, and the red curve is the integral. And what it says is it's 1.12, which sounds awful familiar. The integral, if we integrate it from negative pi over 6 to 0, we get this, which would be half of what we get if we go all the way. So we get y equals 1.2, 1.12. So let's just go back and prove that we did it right. 1.1547. So if you round that off, you get 1.2. Okay, let's see. What else are we doing here? 28, 30. Okay, let's do 30. So we have the integral from pi over 4 to pi over 2 of 2 minus cosecant squared of x times dx. Now you might think there's some kind of Pythagorean identity that would work, but the best thing to do is just break this into two integrals. And if we go to page 240, we look up, see if there's a antiderivative of the secant squared, which there is. So this becomes 2 parts. You've got 2 times dx, and then you subtract off the same limits. I guess they got the same limits, and you have the cosecant squared of x dx. So we look in the book, and it says negative the cotangent. So this part just becomes 2x between pi over 4 and pi over 2. And the integral of the cosecant is negative the cotangent. And we evaluate that between pi over 4 and pi over 2. So the first one's easy. It's just 2 times the upper limit, x, minus the lower limit. Okay, next one we've got the tangent, cotangent, but remember, cotangent is 1 over the tangent. So that's what we're going to do. We're going to do the tangent, so let me just erase that. So we get the 1 over the tangent of pi over 2 plus 1 over the tangent of pi over 4. And actually subtract, I gotta subtract that because that's the lower limit. So here we'll get pi over 2 minus pi over 4 is pi over 4, pi over 4. We'll get, so 2 times pi over 4 is pi over 2. 1 over, well, the tangent of pi over 2 is infinity, so that term goes to 0. And the tangent of pi over 4 is 1. So the answer is pi over 2 minus 1, which is the right answer. Pi over 2 is 1.5 something rather. So it's approximately, this is 1.5 something, this is 1, so it's approximately equal to 0.5. So let's just go to the graphing program, and let me switch here. Okay, so the function was 2 minus cosecant of x squared. And the limits, I'm just going to put them in there. So it was pi over 4 and pi over 2. Graph that. Didn't like that. I think I got to, which thing didn't it like? Make sure I'm getting the function right. Again. Try not to. 2 minus cosecant squared, cosecant of x. Oh, I think I need another parentheses, don't I? Yep, okay. Okay, so there you go. And let's just do stop. Let's put in here, we wanted pi over 4, pi over 2, graph, and let's zoom out in the x direction, like that, zoom in, and let's put the x units in terms of pi. Well, actually, no, let's not put it in terms of pi. So, again, I'm trying to figure out what this area is approximate. Well, here's 1 unit. So if I were to draw a triangle like that, the area of the triangle would be equal to 1/2 times 1, which is a half. And this distance is 0.5, 0.6, about 0.6. 0.6 times a half is 0.3. It's going to be greater than 0.3. Let's say it's greater by about 30%, so that's going to be about 0.4. Okay, let's see if this is the correct answer or not. I'm saying it's about 0.4. .5. Okay, there you go. So it was in the ballpark. Let me just explain how that worked. I may have gone too fast for y'all. Okay, so I need my camera. Take a picture. Okay, so here it is. So this is my logic. And what I'm going to do, add a page. Drag that over there. I'm going to zoom in on it. Okay, so this is what I did. I took this thing and I drew a triangle. And the height is 1. Okay, so because there's 0 and there's 1 and 0. So I'm going to say the height is equal to 1. The base is this distance, which is, if I get my calculator out, it's 1.5 something or other. 1.57 minus the lower limit, which is about 0.78, which is 0.8 approximately, 0.8. So if I take the area of this triangle, it's 1/2 the base times the height, which is going to be 1/2 of 0.8 or 0.4. 1/2 times the base, 1/2 of 0.8 times 1. Okay, but we have this extra bit in here that I didn't count. And so if this is 0.4, how much more is this than that? And if you assume 20% the area, then that would increase this up to close to 0.5. It's a little more than 20%. So that's how I came up with my answer, which is pretty close. Okay, what are we on now? 31, another trig function problem. So we're going from negative pi over 3 to positive pi over 3, and we have 4 secant theta tangent theta. 4 secant theta tangent theta d theta. So again, it's a definite integral. It's the area underneath the curve, this curve, which we'll look at later. So you get 4, you take that out of the integral sign. And the integral of the secant tangent, well, let's go back to page 250. I'm pretty sure it's the secant, but I'm going to be 100% sure here. The integral of the secant x tangent x is the secant. So the integral secant tangent is secant. We evaluate between negative pi over 3 and positive pi over 3. Okay, so how do we get the secant? Well, that's really the same as 1 over the cosine of theta. And I'm just thinking the cosine is, if you remember the cosine, it looks like that. So it looks like I'll get the same value on either side. It looks like I might go to 0. That's my guess. Okay, so 4 times 1 over the cosine of pi over 3 minus 1 over the cosine of negative pi over 3. So again, this is a little unit circle review. How do I do this? Okay, so notice that we said the sine of theta is the y-coordinate. Cosine of theta is the x-coordinate. So what we are on pi over 3 is right here. Negative pi over 3 is that way. So you go up pi over 3, you go that way. Okay, so you can see the x-coordinate's the same. So we know they're going to have the same value. They're going to be both going to be positive. And is that going to be a half, or is it, you know, the 3 choices here, 1/2, square root of 2 over 2, square root of 3 over 2. Well, we don't have to worry about that one because that only occurs when you're at pi over 4, where you have 4 in the denominator. So it's either going to be 1/2 or square root of 3 over 2. So you can see that if I went to pi over 4, which would be this direction, x would be getting bigger. If I went to pi over 6, it would get even bigger. So I'm really here at the start of the magnitude. You start at 0, then you go 1/2, square root of 2 over 2, square root of 3 over 2. So I know it's this one. So I'm not memorizing the, you know, I'm not filling out a unit circle. I'm using logic to figure out what the values are. And the only values that we really can use the unit circle are for are the ones that involve pi over 6, pi over 4, pi over 3. So all you really, I said, so anytime if you got like 4 pi over 5 pi over 4, you know, that's got a 4 in the denominator. If you had 7 pi over 4 or 3 pi over 4, you know, all of those are going to be square root of 2 over 2. It's going to be that middle one because they have a 4 in the denominator. So those are easy. And of course you have to figure out whether they're positive or negative. You can tell that just from where it is on the unit circle. So the other ones, which are the pi over 6 and the pi over 3 ones, you just have to decide which one of these two it is. Is it half or is it square root of 3 over 2? And you should be able to tell that by, again, where you are. If this is pi over 3, pi over 4, and pi over 6, you can see we start at pi over 3, it's a half. Pi over 4, it's larger. Pi over 6, it's even larger. And you can do the same thing in the sign direction. So I'm never memorizing. The only thing I memorize this, which, you know, after a while you just remember. You don't have to memorize anymore. Okay, that's my trick of memorizing things. Okay, so you get 1 divided by a half minus 1 divided by a half. Of course, you can see that's 0 because these are the same expressions. You'll get 2 minus 2, which is 0. So let's see if that's true or not. Hopefully I didn't mess up. Okay, let's go to the graphic program. So what we're going to do is we're going to look at not secant squared, but we're going to look at secant of x times the tangent of x. And we're going from negative pi over 3 to positive pi over 3. And we're going to graph this thing. And So there it is. So you can just tell from the graph what's going to happen. We don't have to do the integral. This is a negative area. This is a positive area. You see it's symmetric. So we know that whatever negative value we get going from here to here, we're going to get a corresponding positive value. They're going to cancel out. So the answer is 0. But let's go to this part right here, which I thought I did. No, I guess not. Okay, secant of x, tangent of x, and we'll go from negative pi over 3 to positive pi over 3. Now, before we plot this, what we should see is the integral should start off as 0, and then it will go to a negative value, and its maximum negative value will be here, because up until x equals 0, you're just adding negative stuff together. So you get a maximum in the area. Then you start to have this positive area, which is going to start to take away from the negative area here. And by the time you get over here, it should be back to 0. So it's going to peak at 0, x equals 0, and it's going to get back. The integral will be 0 at x equals pi over 3. Okay, so we integrate it. So there it is. So the red curve is the integral. So I'm going to zoom in a little bit here in the y direction, you see. Okay, so there's the integral. So start off at 0. The area became a maximum negative, or a minimum if you want to call it that, at x equals 0. And then when you came back to the same value of x except the positive side, the total area goes back to 0, because this area here, the negative area, is canceled out by the positive area. So what we're looking at is this area added to that area. They're the same magnitude. This is negative, this is positive, so it goes to 0 by the time you get to this point. Okay, let's see where we are. For some reason I'm not on the right page. So we are now moving on to problem number, just at 31, so we have 33. So it says determine the area of the given region. So all we have to do is look at the graph and know what the function is. So to find the area, you integrate. You write down the function that you're trying to find the area under, which is x minus x squared dx, and the pink area is from 0. X equals 0 is the left limit, and x equals 1 is the right limit. Now the quarter vertical dimension really doesn't come into play unless we're just trying to approximate what the area is, because it's going to be less than a quarter, because if you make a rectangle, it's going to be a larger area than what that is. It's probably going to be more than half of that, so it'll be somewhere between an eighth and a quarter would give you the answer. Okay, so there you go. That's pretty easy. And so you integrate x, and you get x squared over 2, and you integrate x squared, you get x cubed over 3. So that's the integral, and then you evaluate the integral from x equals 0 to x equals 1. So that means that we plug 1 in. So that's the function evaluated, the integral evaluated upper limit, and then you evaluated the lower limit. Of course, those are going to be 0, because 0 cubed, 0 squared is still 0, so we just end up with 1/2 minus 1/3. And we'll find the common denominator, which is 6, so we can convert each of those into 6 by multiplying this one by 3 over 3 and this one over 2 over 2. And so you get 1/6. And remember what I said? I said the answer was going to be between a quarter and an eighth, which of course 6 is in that area. This is the area, not x. So my ballpark estimate was correct. Okay, number 39. So it's very similar. You know, the first couple of problems we had, they gave us the limits. Number 33, we figured out the limits by looking at the graph. 39, which is what the current problem is we are going to just look at the problem statement to figure out what's going on. Okay, so this is the function. These are the x values that are limited. Y equals 0 just means the x-axis. So that means that we can just do a normal integral. If y was equal to 1, then we would have to do something that we don't learn about until chapter 7. So in this case, we are going to be okay. And so the x values are our limits of integration. So that's all we have to do. We just look at those two values. So we go from x equals 0 to x equals 2 from these two things right here. And the function is 3x squared plus 1 and multiplied by dx to tell us what we're integrating by. So those are polynomials. So when you integrate x squared, you get x cubed over 3. And when you integrate 1, you get x. And we evaluate that function from x equals 0 to x equals 1. Sometimes I write it down as x equals, sometimes I don't. You don't have to include it, but sometimes this is a good reminder of what you're doing, you know, what those numbers represent. Okay, so you can see the first number, first part, the 3's cancel out, so it just becomes x cubed plus x. So I'm just simplifying here before I stick in my upper and lower limits. So the upper limit is 2, so we plug 2 into the equation. So that's my upper limit. We subtract the function evaluated at the lower limit, which is easy in this case because it's 0. So we'll get 8 plus 2, which is 10. So that's the area underneath the curve. Let's just see what this thing looks like. So we're just going to look at the graph. We're not going to look at the integral, and I just didn't do what I was supposed to. Go to the graphing program. Okay. So the function was 3x squared plus 1. And let's go from 0 to 2. Graph it. Oh, something's wrong. Oh, I went from 0 to 0. I don't know why I did that. Okay, so there it is. And I need to zoom out so I can see this whole thing. Okay, so that's the curve. That's the function 3x squared plus 1. So what I'm talking about is the area underneath this curve. And you know, saying it's about 20. So how would I approximate that? Well, you can kind of see it's, if I drew a horizontal line right now, here, I'd get a rectangle, which would be this rectangle that have dimensions 5 by 2, which would be 10. And if I look at this, it looks like I've got, you know, this much above the curve here, and I've got this much below the curve there. So those areas, this area here, bordered this direction, looks like it just about balances that out. So I think my approximation would be 5 times 2, which would be 10. So let's see if that's what we got, or something like that. So stop sharing, share, and that's actually what I did get. Turns out it's exactly 10. That was just a coincidence. I'm not that good. Okay, let's look at problem number 28. So we have the integral of from 0 to pi over 4 of 1 minus sine squared of theta divided by the cosine squared of theta, d theta. Now this may look difficult at first, and I see it, but you might not see it. But we could solve this two ways. Well, we'll solve it the hard way, and I'll show you the easy way. I'll do the hard way first, and then I'll show you the easy way. So the hard way would be to take 1 over, you break this into two things. 1 over cosine squared of theta, d theta, and then you'd have, I should have a negative sign there. So negative sine squared theta divided by cosine squared theta d theta. Okay, so 1 over the cosine is the secant squared theta d theta, and the second one is the tangent squared of theta d theta. Actually, you may not be able to do it this way yet. We could do this in chapter 4 or 5, but we can't do it because we don't have, I don't think we have any derivative, which is the tangent squared. But let's just go back and look. Is the tangent squared anything? Okay, so we don't know how to do this, so we can't do that. If we did, we could do it. But okay, so what is the other way of doing it? Well, the Pythagorean identity, or Pythagorean identity says that. So 1 minus sine squared of theta equals cosine squared of theta. So if I subtract sine from both sides, I get that. And so the numerator can be just rewritten as cosine squared of theta divided by cosine squared of theta d theta. And so that's 1. So then you just integrate d theta. So it just becomes the integral of d theta between that. That's just a horizontal line. You know, it's 1, y equals 1, which is just a horizontal line, is the equation, because we have 1 times d theta. So the integral of d theta is theta, and we evaluate that between 0 and pi over 4. So that means we just plug in the numbers. So you just get pi over 4 minus 0, and the answer is pi over 4. And that was problem number, I forgot what number it was. Just double check here. 28. The answer is pi over 4. Okay, we're on problem number 43. This is associated with the mean value theorem. That's a mean value theorem for integrals, which is a little different than the other mean value theorem that we did. There was a mean value theorem for derivatives. So what the mean value theorem, it basically comes down to, it relates to the average of a function, I think. Well, let me go look at it just to make sure I remember what the heck this is. Mean value theorem. Okay, definition of the average, so that's definitely means that I'm thinking about the right thing. It says the integral from a to b of f of x dx, which is the area underneath the curve, is equal to some value of the function between a and b times a minus b. So we actually have done this if you watch some of the other videos. We've been approximating the area underneath the curve, which the function is not a horizontal line, as a rectangle where you have a horizontal line and then you have the dimension, the width dimension. So this is the height of the rectangle, this is the width of the rectangle, which is the 2 minus 0 in this case. So what it's saying is there's always a value of the function f of x between f of a and f of b, where that value of the function times the width of the rectangle equals the area under the curve. Okay, I'll explain that again when I can show you a picture. So all you have to do is, we just have to find this, what is the value of this function, which is the average value. It turns out if you divide by b minus a, you get the expression for the average. So you could say the average value is just the integral divided by b minus a. That's what the average value is. So it just basically says there is an average value that you can use. So in this case, we'll say f of c is equal to the integral from 0 to 2 of the function, which is x minus 2 squared of x dx, all divided by 2 minus 0. So the integral of x is x squared over 2. The integral of the square root of x is x to the 3/2 divided by 3/2. How did that happen? Because this is x to the 1/2. So you add 1. 1 plus a half is 3/2. You divide by the new exponent, 3/2. So this always, once you do this part, you have that part. You don't have to do anything special down there. And then we evaluate that between x equals 0 and x equals 2. And you see since this is a polynomial, if you have 0, these are going to, the lower limit just is 0, so you don't even have to write it out at this point. So we'll have 2 squared from here, divided by 2 minus, 2 divided by 3/2. You take the reciprocal of 3/2, which is 2/3. So you have 2 times 2/3, which is 4/3. So just clean that up a little bit. And then you have 2 to the 3/2 power. And then I forgot, let me move this down. I forgot the 2 part here. So we got to divide this whole thing still by 2. Likewise, we're going to do the same thing here. Divide that by 2. Okay, so what do we do next? Well, what is 2 to the 3/2 power? Well, let's do the first part first. You get 4. 4 divided by 2 is 2. Minus 4/3, and you get basically the square root of 8. Because if you cube 2, you get 8. 2 times 2 times 2 is 8. And then you take the square root of 8. And then you divide the whole thing by 2. So that becomes 1 minus 2 divided by 2 is 1. 4 divided by 2 is 2. So you get 2/3 square root of 8. And what is that equal to? Well, let's just do it as a decimal. I mean, what you could do is you could find a common denominator. You have 3 minus 2 square root of 8 over 3. That's probably the best math way of doing it. So let's just do that. 3 minus 2 times square root of 8. The whole thing divided by 3. Divide by 3. I don't know what I did. Divide by 3. Negative 0.856. Negative 0.886. Okay, so that's the average value. And hopefully that's correct, because let me just look back here, make sure I didn't do anything wrong. Okay, let's look at the curve. I think it's okay. So let's stop that, start sharing, go to the function. Okay, so what we're looking at, the function was, I've already forgotten what it is, let me go back. X minus 2 times the square root of x. X minus 2 square root of x. And we're going to go between 0 and 2. So that's okay, and I'm going to graph it. It's probably going to have to, we're probably going to have to zoom in on it here. Okay, let's zoom in the y direction. Wrong way. Zoom in. Okay, so there is the function, and I'm going to actually take a picture of this because I want to be able to write on it. Okay, there it is. Let's go back. And there we go. Close that thing off, go to here. Okay, so there we go. So what we just said was, if we go back to the previous page, that the average value is negative 0.886. So let's draw that on our curve. We'll take a blue curve. Negative 0.8. There's negative 0.885886. So there we go. Looks like that's going to be right. So the blue curve is negative 8.8. So what it's saying is that if we looked at the area under the red curve, which is this, which is going to be negative because it's beneath the x-axis. So that's the area under the red curve. What they're saying is there's a value f of c, which would be f of c. There's at least one value f of c. So this would be one value. So you can see that right there. That's f of c. That's f of c, and this is c. There's also another one. There's two c's here. So we'll clone that, move that over here. The other will be right there. So there are actually two values of c between a and b, where the exact value of the function, the value of the red function is 0.886, or whatever it is. If you take that value of the function, either one of these values of c, and you draw a horizontal line, the blue area, so if I do the blue area by going from the x-axis down to the blue curve, which is just a rectangle, like this, the area, the blue area, is the same as the red area. And what you can see is you've got this part of the function, which is below the blue curve, and you've got this part of the function, which is the other direction, and then you've got a little bit right over here. And what you would find out is that if you take this area plus that area, it equals to that area. They balance out. Okay, so again, the integral of x minus 2 to the square root of x is the area under the red curve, which is not, varies. The dimension varies. There is a value of y, f of c, where if you take that value, the constant value, and you multiply it by the distance from the interval from 0 to 2 times this height, that blue. This is section 4, and we're going to start with problem number 6. They're all problems, but they're all pretty short. So what we're talking about is definite integrals. So we had the integral of 3 dv from 2 to 7. So you would factor out the 3. So all you have is the integral of dv, which is v. So the integral of dv is v. So we have 3 times v, and we evaluate v at the upper limit and subtract it at the lower limit. So we get 3 times 7 minus 2. And that gives us 15. Okay. So let's see what I'm doing here. Number 63. It's a word problem. It says the volume in liters is represented by this curve fit equation. So it's a nice polynomial. As a function of time, approximately the average volume there. So we're just doing the average. So all we have to do is we just integrate v dt. V is a function of time, and we go from 5 seconds. So it's a 5-second respiratory cycle. So we start at 0, we get a 5, and then we divide by 5 minus 0. So it's the integral from 0 to 5 of 0.1729t plus 0.1522t squared minus 0.0374t cubed, all by multiplied by dt times dt all over 5. Now, luckily, because this is a polynomial, we're only going to have to evaluate it at the upper limit, which is nice. So let's just write out the integration. So you get 1729 divided by 2 times t squared, and then you'll have 0.1522 t cubed over 3 minus 0.0374 t to the 4th over 4, and you evaluate that between 0 and 5. So we only really have to plug 5 in there, because all the other ones will go to 0 when you plug 0 in there. So you get 5 squared, 0.1522, 5 cubed over 3, minus, and I forgot to divide the whole thing by 5 again. So then we have 0.0374 t to the 4th. T was 5 at the upper limit. 5 to the 4th all over 4, all divided by 5. And then we just plug it in a calculator. 0.1729 divided by 2 times 5 squared plus 0.1522 times, or let's divide it, divided by 3 times 5 cubed minus 0.0374 divided by 4 times 5 to the 4th power, and that gives me 2.659, and I divide by 5, and I get the average volume is 0.532 liters. And let me just check the answer. I'm not gonna graph it this time. I'm just going to look in the answer book. 0.5318 liters.